process.
Okay, so thank you for coming. I am Gabriele Paoloni. I work at Red Hat and I lead the safety architecture working group within the ELISA project. So today I'll give you a very brief introduction about this working group. Then we'll talk about the major milestones and achievements in 2024. We'll go through the current focus and activities. Then we'll see what's coming up and in 2025 and what are the areas and opportunities for collaboration. And finally, I will talk about the onboarding resources and how to get involved. Okay, so the mission, what's the mission of our working group? So the mission is according to technical safety requirements that are produced by domain-specific working group. For example, by technical safety concept, we should determine what are the critical Linux subsystems and components that would support the associated safety function. We need to define safety requirements for the kernel, scalable architectural assumption, and deliver corresponding safety analysis for their individual qualification and their integration into the safety critical system. So basically, our working group is focused on the definition of requirements and safety requirements for the kernel and on their breakdown according to safety analysis that we perform on the kernel. So this is the mission, okay? But let's see what we did in the last year. So the last year we focused on kernel safety claims by runtime verification monitors. Then we looked at the revisited STPA analysis versus the expert-driven FMEA comparison. After that, we moved to evaluate and improve the Linux kernel documentation. And last but not least, we did some work on Linux kernel requirements. So where did we start? So one of the initial things that we looked at is, how can we support kernel safety claims by runtime verification monitor? And the idea was to use a sort of ACID decomposition inside the kernel, where we had this ACID-B monitor that was running inside the kernel, and that the idea was to use this monitor to monitor some subsystem and drivers of the kernel that were supporting a safety function. As we did that, we realized a couple of things. One is that in order to design an effective monitor, we need to understand the kernel code, and this is required in order to determine the failure mode to be monitored. And also another main challenge was to how to claim freedom from interference between the code being monitored and the monitor itself, given that both of them run in the same kernel address space. Okay, so and this is the main outcome. Then the next thing is, okay, so we understand that one of the key activities that we need to do is safety analysis. So in order to deliver a complete set of failure modes for the kernel, we need to pick a suitable methodology to do a safety analysis. And so we did compare a revisited STPA analysis versus an expert-driven FMEA. The outcome was that STPA better suits a system level analysis, as in an analysis aimed for a system level safety concept, whereas an expert-driven FMEA better suits a software level analysis, that is to define and break down safety requirements across hierarchical software components. However, the key outcome is that in order to claim the completeness and the effectiveness of the analysis, a crucial point is to have a comprehensive description of the elements under analysis. So in our case, the Linux kernel. So, and the point is, okay, but then how do we describe the Linux kernel, right? And at that stage, we realized that we need to improve the Linux kernel documentation associated with the code, with the kernel design itself. So what we did is we analyzed the current templates and guidelines that are available in the Linux kernel documentation, and we evaluated if and how such guidelines and templates fulfill the architectural defined aspects required by functional safety standard. And we try to define improvements in consideration of the maintenance challenges that derive from a continuously evolving code baseline. Okay, so at the end, this activity triggered a session that was presented at Linux Plumbers 2024 in Vienna. And following such a discussion where we had also few maintainers, few Linux kernel maintainers that were involved, everybody agreed that there is a need to formalize and define testable requirements in Linux. Okay. So what we did is, like, thanks to the contribution of the working group participants and especially Chuck and Chuck Weber and Kate, we put together an initial draft for the Linux kernel requirement definition, and we came up with an initial set of SPDX compatible fields that would characterize low-level requirements inside the kernel. Okay, and we discussed this proposal at the last ELISA workshop at NESA, and basically the next step we said, okay, we have a draft proposal for how to write requirements inside the kernel, and let's get our hands dirty. Okay, so let's put together some examples and let's try to also develop the automation associated with these requirements. And so after that, now our current focus is the first thing is we are trying to prototype some Linux kernel requirements, and we are prototyping also the automation that is needed to check patch set against the requirements and vice versa. Okay. Then we are indeed also finalizing these initial requirements framework automation and example, and we are finalizing the Linux kernel requirements white paper, and the goal is to get it published by the Linux Foundation. So this is a bit more zoom on what we are doing. So this is an example of requirement proposal that we put together for a function of the tracing subsystem. And the reason why we decided to prototype on the tracing subsystem is that we got an initial positive feedback from the tracing subsystem maintainer to collaborate with us. Okay. And indeed, as we are doing this, the recommendation also from the maintainers were that these requirements must be testable, maintainable in line within the source code. So maintainers, they want to see requirements really evolving along and inside the source code. They must be compatible with pre-existing kernel documentation. Probably you are aware that today the kernel code should be documented according to kernel doc headers, and we cannot disrupt, the existing way of documenting code. And these requirements must be also hierarchically traceable. Maybe, we can, and hierarchically traceable between the requirements and also maybe traceable to associated tests that can be done maybe using BASIC, as also Matt mentioned earlier in the tool working group presentation. And now, while from the formal aspect, it is quite easy, to basically spread requirements across the source code. At the end of the day, the main challenge is to identify the design elements that must be documented, because our starting point is the pre-existing code. Okay. And indeed, it is not reasonable to have requirements that are as complex as the code itself, because otherwise you could just read the code, right? And so the key challenge is basically in identifying, these key design elements and and describe them in the requirement in a way that is feasible and maintainable and testable. Okay, and basically we are now working on this. And the other point is prototyping the automation to check the patch set. And we had an initial proposal from Alessandro, that is one of the working group main contributor, I would say. And indeed, this is under discussion. We already discussed some improvements. And so the idea is that every requirement should have its own specific identifier that is called FPDX track ID. This should be immutable along the life cycle of a requirement. And then there is another identifier that is the hash key, that is basically a sort of hash that is checking requirements against the code that the requirements apply to, and vice versa, so that if there is a change to that code, this hash key will also change, and then there will a flag will be raised to the maintainer saying, hey, the code has changed. You may need to revisit this requirement, okay? Or vice versa. The requirement, somebody could have proposed a patch to the requirement, and then the maintainer will still get a flag say, hey, this requirement has changed. Please have a look at it, right? So this is basically a sort of automation that we need in order to maintain requirements together with the code and along the current submission process of Linux main line. Okay. And yeah, so then as very next step here is to finalize the initial requirement framework automation and example. We are collaborating on a development branch that is the one that I'm presenting in this deck. And indeed, we need to complete this exercise on trace array set clear event and trace set clear event, that are the two initial APIs that we have picked as an example. And indeed, we need to complete the automation for maintaining all this SPDX requirements here. Once this exercise is completed, what we'll do is we will finalize the white paper, okay? Because at this stage, we have our ends that are dirty enough. We have some degree of confidence that what we are proposing, is kind of doable. And this at this stage, we feel, also confident to finalize this white paper and possibly to get it published. The goal of this white paper would be to engage, with the community of Linux developers. Okay. So, then what's up for 2025? Indeed, after we have completed our exercise, that is, our exercise is based on a fork from the Linux Git repo. So the first thing to do is to get these initial requirements framework automation and example upstream, okay, upstream in the Linux kernel, and then after that, we also need to refocus the requirements in alignment with the key subsystems identified by the Linux feature working group. As I say, today we are working on the tracing subsystem because we have a sort of informal acknowledgement by from the respective maintainer to work with us. And but once we are able to push this upstream, then we also want to extend requirements to other subsystems, for example, memory management or the scheduler that are more relevant, to support a safety function. And actually, later also Alessandro, will explain what the Linux feature working group is doing to identify the key subsystems supporting a safety function. And the last thing, we will use this Linux kernel low-level requirements to support safety analysis in the kernel. If you remember the beginning of the presentation, at the beginning of the presentation, I said that the mission of our working group is to do safety analysis in the kernel according to safety requirements that are allocated by technical safety concepts. The main issue that we found is that today, since the kernel is largely lacking design documentation, the only way to do a safety analysis is by reading the code. Okay, and this is not really sustainable, and this is not scalable. Okay, so after we have enough, low-level requirements for the kernel, at that stage, probably it will be much easier, to also do safety analysis in the kernel. And the last thing is, please come and work with us. So these are the onboarding resources. This is the working group web page is the one that I post here. And we are meeting regularly on a weekly basis every Friday. And here you can find the calendar with all the meeting occurrences. And also we have a GitHub repo where we have additional details of the work being done. And I think I'm done. If there is any, I don't know if there is any question.
There's not yet a question on the chat, which I can see. I just was wondering on the requirements topic. Do you think that there is a first patch go live during first half, or will be more in second half, or how is really? Do you made up your mind how close you are to giving a first patch trial?
I don't know. There are 2 points here. The thing is that it depends if, I mean, we need to decide if, as part of the first patch being proposed, we want to cover requirements only or also the automation that comes with it, right? So, and right now we are working on both in parallel. So possibly, I mean, ideally, I would like, to send as part of the proposal, to send both the example and, the automation that would allow others, to create new requirements for other functions, basically. We may not be too far, to be honest. There is actually a specific function that I'm fighting with. So if you look at the work in progress branch, will basically, if you grep for the to do in my commit, you will see that there is a function that is where probably we need to define multiple requirements associated with this function because it's really too complicated. And then yeah, but the point is that even if we make, it would be pretty easy to do an initial push upstream. The problem is to get it accepted, as in, I don't know today if what would be the right degree of detail that would be acceptable to maintainers. So the main challenge, as I said, is, I mean, it's easy to to fix the formalism of SPDX labels and stuff, right? It's also reasonably easy to put together the automation because if you know what you need to check for, you can do it. The really painful part is what are the design elements that maintainers expect to be documented and that they feel like maintainable, right? Because if there is too much detail, as I say, they could just say, go read the code, right? And if there is not enough detail, we may miss, the attribute of defining testable requirements, right? So yeah, we need to find the right balance. This is to be honest, the key challenge that we have today, and I'm pretty sure that the final balance can only be found after we get feedbacks from the upstream community.
We also got a question in the chat
Yeah.
where it says like, are the SPDX attributes changes going into the software change impact analysis, like tools, workgroup, Bazel, for example? It looks like it addressed the issues in the same domain. So I think it's more about
Yes.
the linking of it. Yeah.
Yeah. I think yeah the uh, so I think Basis today, and I don't know if you have Luigi up here, but I think Basis today is already able to import requirements in SPDX format. So, but the idea, yes, is to use basically these attributes uh, to to link requirements to corresponding tests, and also I think because in the thing is that in the if you look at the template that we put together for requirements, there is already, I mean, they're already hierarchical because you can define basically dependent requirements and, and or requirements that are associated. So it should be really straightforward, probably maybe with some modification to use a tool like Basis, to maintain their, the hierarchy of requirements and also corresponding
Yeah. So we really have to connect there. Yep.
yeah,
Cool.
we need to connect. I mean, now the presentation I gave is in the context of the architecture working group, but indeed the requirement would have an impact also on other working groups, like what Matt, sorry, presented earlier. In the two working group, what Paul talked about in his presentation before this one. So yeah,
Yeah, and I guess we also try to, I mean, that's not on the slides, but I think I have it on my one for tomorrow. That my idea would also, if we come to that, here are descriptions of the requirement, here is tooling to check and so on, that we bring it also into our CI system so that we can place it in there and use it for further analysis. So that like from the systems workgroup, the I and so it doesn't speak against, right? You just take the kernel and you put in the requirements, maybe as a showcase and so on, and then get the results and process
mm,
further. Okay, great. We have no further question in the chat. So I would say we close this session, stop the recording.